Lastly, I want to swing back to the concept of the choropleth map and just talk about the key characteristics of what makes a choropleth map a choropleth map. I did bring up a few of these in the first video in this module when I was talking about the introducing the choropleth map and talking about the problem of the MAUP, the first issue that we might have with these. But here I just want to swing back and talk about the main things about this. So firstly, a choropleth map is a choropleth map when, number one, it has color. And you can see in this example, each of these states represented in this map are a different color. In this case, as you can see in the title, the colors represent the percentage of rural population in poverty for the United States between 2011 and 2015. The word choropleth is actually Greek for color, which makes sense in the naming of this map, and that might help you remember this. The second key thing about choropleth maps is that they are discrete spatial units. They utilize discrete spatial units as opposed to continuous data. Continuous data might be something like temperature or elevation, something that's more of like a smooth spectrum as opposed to like, these cut up units of data. And so we aggregate these numbers into discrete geographical units that are separate from other geographical units. And you can see that again in this map example. Each geographical unit, in this case, each state is broken up and assigned a value, a discrete value that represents the average percentage of rural poverty, or rather just the percentage of rural poverty in that state. And so there, of course, and you can see in this example in the key here, there's 19 or more is the highest category of percentage of rural poverty. And you can see a few states have that highest category, that color that represents, that dark color that represents the highest category. And these are broken down in this particular way. There could be other ways that we would choose to break these down. We could say that 15 or more is going to be the highest category. That would mean there would be fewer categories. So the way that we break the categories down is going to change the number of categories there are, the number of different colors there are on the choropleth map. It's just something that it's important to play with if you're making a choropleth map. But there are different ways, sort of the different terms for ways of breaking down these categories include what are called natural breaks, equal interval, quantile. I personally like quantile, just it puts an equal number of observations in each category. But it might be more appropriate to use equal interval as opposed to quantile, depending on the sort of data that you're working with. Think of classification categories like buckets. Each bucket is a different size, right? The 19% or more in this case, that's a pretty large bucket. And if we change the way that we define each category, we might be changing the size of each category or the types of each category, the numbers of each category, numbers of different types of categories. So anyway, this is just, again, to swing back to the concept of the choropleth map and talk through those three key things that make a choropleth map a choropleth map. So I hope this is helpful for you.